Hello class, welcome back. Today we're going to go ahead and be covering section 5.2, right, covering mean, variance, standard deviation, and expectation in probability distributions, right? And in section 5.1, right, it was getting us used to the probability distribution table and reinforcing these ideas that we covered right during unit 1, stating that right, your probability values must be bounded, right, between 0 and 1, right, and that they must be positive, right, and also that probability, the sum of all these values must equal what? 1. Right. So if you were to go ahead and add 0.20 plus 0.33 plus 0.43 plus 0.03 plus 0.01, you'd see that it'll give you a solid 1. All right. If you're over or under, right, we cannot use that, right, this distribution probability table. So in other words, there was no math involved for 5.1. It was just reapplying those ideas into the probability distribution table, right? And we're going to be working with this, this entire section, all right? So with this entire section, we're going to be finding mean, the variance, the standard deviation, and the expected value, all right? So let's begin, right? So we're going to go ahead and begin with finding the mean, all right? We're going to go ahead and find the mean. And finding the mean is just going to be my mu, right? And this is going to be the sum of those x values multiplied with those probability values, all right? All right. So how do we approach this, right? Well, right, so it's going to be column by column by column, right? So this means that to find my mean of this probability distribution table, I'm going to get the x value, all right, which is going to be 0, and multiply with this probability value, which is 0.20, plus the other x value, which is 1, multiplied with that probability, which is 0.33. And you go down the entire column, right? So this is going to be 2 times 0.43 plus 3 times 0.03 plus 4 times 0.01, all right? We're going to go ahead and sum up all of these values, and we find out that my mean is 1.32, right? 1.32. Okay, very nice. What we're going to go ahead and do next is going to be to find my variance. We know that our variance is noted as sigma squared, right? Where this is going to be the sum of the product of my x squared values times those probabilities minus my mean squared. Right, so how is this going to look? Right, and actually let's go to the mean one. Let's go to above this one, and I'm going to state that right there. That looks much nicer, right? So in other words, what I'm going to do here is going to be very similar to what I did with the mean, but here I'm going to be squaring those x values. So this is going to be 0 squared times that probability plus 1 squared times that probability, so forth, right? And remember, for the exam, you do have to write all this out, right? Just having the mean here, all right, with no work to justify that would you would go ahead and receive, right? We would be receiving no credits, right? So let's go ahead and make sure we show all of our steps. 0.03 plus 4 times 0.01. I gotta square this, right? Right, and I know this is going to be minus my mean squared, right? My mean was 1.32 squared. And when we plug all of this into our calculator, right, You may go ahead and pause the video when you need to. I get 0.74 my variance. And the standard deviation is, it's a nice one, right? Because for my standard deviation, right, that just means I'm going to take the square, what was that? Take the square root of my variance, all right? So in other words, let's go ahead and take the square root of that. So this gives me here my variance to be what? I'm sorry, my standard deviation to be what? 0.86. That's how you go ahead and go about this problem, right? Not so bad. So let's go ahead and follow another one. Let's go ahead and do a second example. Go ahead and make this a little bit larger for you all to see. All right, so this says the number of suits sold per day at a retail store is shown in the table below with the corresponding probabilities, all right? And again, find the mean, variance, and standard deviation of the distribution. If the manager of the retail store wants to be sure that he has enough suits for the next 6 days, how many should the manager purchase, right? Okay, so let's go ahead and see this. Let's go ahead and start with finding the mean, right? Go ahead and find the mean, right? You said my mean is just going to be the sum of those values. So this is going to be 17 times 0.1 plus 18 times 0.2 plus 19 times 0.3 right? And again, right, you can make sure that this probability table works by summing all of those values, right? Okay, so to go ahead and find my mean, right, let's go ahead and plug all those values in. And we find out that my mean is 1.6. Right, my mean is 1.6. Okay, let's go ahead and find the variance. You said for the variance, it was going to be the same thing, but those x's values are squared. And I'm subtracting that by the mu squared, right? So in other words, this is going to be 17 squared times 0.2 plus 18 squared times 0.2. 18 times 3. Oh, these are squared. Maybe all these values. Minus my mu squared, right? So that's going to be minus 1.6 squared. Let me go ahead and check my work real quick. That mean doesn't look right. Go ahead and check this again. 17 times 0.1. There we go. This is off. I'm not sure where I got what happened with my calculator. All right. So in case you want to go ahead and double check, always make sure to double check your work. All right. Now this here gives me 19.2. 19.2. Meaning this value here should be 19.2. Okay. So let's go ahead and plug all these in and we'll be right back. And we're back and we find out that this is 1.6, right? This is where my notes, I had gotten these mixed up with my notes, meaning, all right, that is my mean and that this is my variance, meaning I find my standard deviation by taking the square root of that, right? Right. that. Then we get 1.265, or in other words, this is just my standard deviation is just 1.3. Right. So, and it says here, if the manager of the retail store wants to be sure that he has enough suits for the next 6 days, how many should the manager purchase? Right. So if I know on average, right, I know if on average he makes 19.2, suits, 19.2. So what I'm going to want to go ahead and do is do 19.2, and I'm going to go ahead and multiply this by 6, right? That's going to go ahead and give me a guesstimate, right? 19.2 times 6, this gives me 115.2, right? And you always want to round up, right? Because it's not like he can have a 0.2 of a suit, right? So I would say he should have 116 suits ready for the next 6 days. Okay. Okay, let's go ahead and move on to example number 3. Right, let's go ahead and make this a little bit larger here. There you go. In terms of terminology, right? Joe bids, right? A landscape contractor bids on jobs where he can make $3,500 profit or $3,500 in profit. The probabilities of getting 1, 2, 3, or 4 jobs per month are shown below, right? On that table, I see 0.3, 0.3, that's 0.6, 0.6 plus 0.2 plus 0.2, that gives me 1. So this probability distribution table works, right? So here's a new word. Find the contractor's expected profit per month. Expected profit, right? And if you were to go ahead and go to page, if you're on your book, right, section 5.2, page 277, right, expectation on the lower part, the expected value, right, the definition is the expected value of a discrete random variable of a probability distribution is the theoretical average of the variable, meaning it's the mean, right? So if they ask you find the expected profit, right, per month on section 5.2, we know, hey, they just want the mean, all right? So in other words, to find, if you were asked to find this, right? Because I may not always ask you, hey, find me the mean or find the expected profit. Well, you could get expected profit, right? Or you may also see the symbol, right? Find E, right? Find E, capital E of X, right? That's going to mean expected value, which therefore means mu, which therefore means the mean, right? The average, all right? So it's the same word for everything, right? For the same process. And we know how to find the mean, right? We said this is just my mu, and we said mu was the sum of getting my X values and multiplying them with those probability values, right? So in other words, the expected value is just 1 times 0.2 plus 2 times 0.2 plus 3 times 0.3 and plus 4 times 0.3, right? We go ahead and sum these up, right? And I end up getting here to be, this ends up being, 1 second. This ends up being 2.7 by mean, right? 2.7. But that's just my mean, right? The question asks to find a contractor's expected profit per month, right? So this is still very similar to the suits, right? It's very similar to the suits. So I know that, right, the profit that he makes is 3,500. I'm going to go ahead and multiply this, right, by that mean. Right, so I can go ahead and have an estimate, an average of what his profit is going to be per month, right? And when we go ahead and plug that in, right, I get 3,500 times 2.7. I get this to be 9,450. Right, 9,450. And so here's the answer I'm looking for. Okay, and last but not least, right, the last example for this video. Ooh. Let's go ahead and move these things over. What? Okay, there you go. Whew. Construct a probability distribution for the sum shown on the faces when 2 dice, each with 10 faces, are rolled. Find the mean, variance, and standard deviation of the distribution. Whoa, all right. So here, all right, if you're watching the video, great. You don't have to draw this table, all right? This is the benefit of watching the videos, right? Plus, you should be watching them, right? Right, so very similar to those probability values, that probability table that I had said, right, that I'm not going to give you this, I'm not going to give you the table. No, I am going to give you the table, but everything after, you should be able to know how to use, all right? You should be able to know how to use everything, all right? So, so one thing you should go ahead and do, right, is find the possible outcomes for the 2 dice, right, for all the possible outcomes, right? So in other words, if you want to go ahead and roll if you want to go ahead and get a 2, right, the sum of these values, right, you can get that by landing on a 1 and a 1, all right? If you want to go ahead and get a 3, right, you can get a 1 and a 2 and a 2 and a 1. All right. If you want to go ahead and get a sum of 4, all right, you can get a 1 and a 3, a 2 and a 2, and a 3 and a 1, and so forth, right? So this is the complete list, right? This is going to be my complete list, right, of all the possible outcomes, all right, of all my possible outcomes. And let's go ahead and make this a little bit smaller here. Need some room. Right, and now we need to go ahead and build a distribution table, all right? We need to go ahead and build a probability distribution table, right, of all the possible outcomes, all right? So these are going to be outcomes between 2 and 20, right? These are all going to be possible outcomes of between 2 and 20. So right there. All right, the end. Let me go ahead and write this out here at the end. This is 1, 2, 3, 4, 5, 6, 7. There's a reason why I'm drawing those out, right? So this is going to be X the probability. All right, and we're going to find out, how do I find these probabilities, right? How do I find these probabilities, right? How do I find this, right? Well, let's look at the fraction part first, right? Let's look at the fraction part of this first. All right, count all those. If you were to count all these, right, which is the same thing as counting all of these boxes, right? Right, you'd find out it's 100, right? And we said whenever we were dealing with the 6 by 6 dice, is you multiply 6 by 6, all right? Or in other words, we multiply 10 by 10, and that gives me 100. That's going to be a total of 100, right? And so in other words, if I'm talking about 2, right, I want to go ahead and land on a 2. The probability of me landing on a 2 is, well, there's only one outcome, right? This is why I drew that 1 below here. There's only one outcome of 100. Very nice. Right. What about 3? Well, for 3, right, there's 2 possible outcomes. 2 over 100, right? And for 4, right, there is 3 out of 100. Or there's 3 out of 100, and so forth, right? So what I'm going to go ahead and do here is pause the video, and I'll be right back. And we're back. All right, if you notice, I had to make those charts a little bit smaller, right? But yeah, here we go. Right, so for 3, it's 2 out of 100. For 4, it's 3 out of 100. For 5, it's 4 out of 100, and so forth, right? And they peak whenever at 11, right? Because 11, I can only get 10 out of 100, and then it starts dipping down, right? So it starts dipping down. So to find my mean, yes, this is going to take, you know, some sheets of paper, right? Right, so this is going to be 2, right? We said the formula, right? Let's write the formula. The formula is those x values P of x, all right? Woo. So this is going to be 2 times 1 over 100 plus 3 times 2 over 100 plus 4 times 3 over 100. I'm going to complete the whole thing and go all the way to 20 times 1 over 100. Right, and remember, your denominators are already over 100. Right, your denominators are already over 100. All right, so you know all you really have to do is sum the top parts. All right, so sum the top parts. Right, so I know all of these are going to be over 100. Right, so the top I should only have 2 plus 6. You would find out plus 12 plus 20 plus 30 plus 7 times 6. There we go. 42 plus 56 plus, right, you would go all the way. The last one, 20 times 1, right? And when you sum all these up and you divide by 100, you find out that this gives me 11. This gives me 11. Right. We're going to go ahead and, so this was A here. For B, I need to find what? My variance, right? And we know this is the sum of these x squared values times P of x, right? Minus my mu squared, right? So in other words, what I have here would be, right, this is 2 squared times 1 over 100 plus 3 squared times 1 over 100. 2 times 2 over 100, I'm sorry, 2 over 100 plus, we're going to go all the way to 20 squared times 1 over 100. Right. And minus, right, minus my mu squared, which is minus 11 squared, right? We go ahead and do, right, if we were doing it in the same format we were doing before, that is like saying 4 times 1 plus 9 times 2 plus, all right, it's 20 squared, right? 20 squared gives me 20 squared times 1, this is 400 times 1, all over 100 minus 11 squared, all right? And you find out, all right, like I said, you may go ahead and pause your video, right? And we should get 16.5. But not least, right, our favorite one, the standard deviation, it'll be the square root of that. This here ends up giving me approximately 4.06. Nice, and that's how you build the probability distribution tables for sums between 2 and 20, right? And then how you find their means, variance, and standard deviation. Okay, thank you very much for your time, and I'll go ahead and be seeing you in the next section.